All right, everybody, today lesson 95 is on the slant height of pyramids and cones. I had to put on all of my artistic ability and I tried very hard, many times, to draw a pyramid. Okay, as you see, the dotted lines are what you don't see because it depth, and a cone. Okay, a cone's a little bit better than the pyramid. But first of all, I want to remember that what it sits on is a base. Okay, so in this pyramid, we may have a rectangular base, we may have a square base, and here we have a circle, right, a circular base. So then the apex is the other thing we need to talk about, and that, of course, is the highest point of the cone or the pyramid. So here I have my little figures that I love to bring out. So first of all, we have a cone, all right? So the base is the circle, and the apex is the highest point. Okay, on this pyramid we have a square base, and the highest point being being the apex. Now, the dotted lines, I don't know if you guys can see those, but I did some dotted lines on here because this is what we call the slant height. Okay, it's, you know, the height from the apex to the base. Not perpendicular, but just that measurement there. So it's slanted, okay? And the same thing here on the pyramid. I don't know if you guys can see a dotted line that I created there, but that, of course, would be the slant height of the pyramid. Now, the true height is going to be a drop down from the apex, okay, perpendicular to the base, all right? So picture then it's almost like this little paper clip is perpendicular to my base, touching the apex, okay, meeting the base, and it's perpendicular. So it's like dropping down that perpendicular. So do you guys see what happens there? I'm going to add a little bit here. So if this height is 12 centimeters, okay, and this, the diameter of the circle is 10 centimeters, okay, then if we're trying to find the true height, okay, the slant height, we would want to use the true height, okay, and we're going to use the Pythagorean theorem, okay, because the slant height is going to be from our apex, not perpendicular to the base, but this measurement here, okay, the dotted line that I showed you. All right, so if the height is 12, that means this right here is 12, okay? If the diameter is 10, then isn't the radius 5? Oh, wow, I see some interesting numbers here. 5, 12. We could use the Pythagorean theorem, couldn't we? And this is a triple. It's a 5, 12, 13, I hear you say? Oh, good. All right, if you had forgotten that, you could say 5 squared plus 12 squared equals my hypotenuse squared. Because do you see how you've created a right triangle from the true height that is a drop down from the apex perpendicular to the base, and you're trying to find the slant height from the apex to the edge of the base. So if you had forgotten that Pythagorean triple, you would just plug in, right? And so 169 is c squared, so the square root of 169 we know is 13, right? So if you know your triples, you save yourself a lot of time. And so the same thing happens with a pyramid. We can drop down the height. They'll tell us what the height is, right? And then we'll be perpendicular to the halfway point of one of the sides. So say that they say the sides, or the base here is, let me think a minute, 12, okay? And the height is 8 inches, okay? So what would be the slant height? Again, you're trying to make a right triangle in there. All right, because you want the slant height. So if the base is 12, that means half of it is 6. If the height is 8, oh, there you go. You've got another Pythagorean triple, don't you? 6, 8, how much would the slant height have to be? 10 inches. Very, very good. All right, so you can look over example 1. Example 2 I'm going to forego, but I want you to try this A through D. All right, so stop the video, work on those, and I'll be working on them as well. And we'll go over them in just a minute. All right, so for A, it says describe the difference between the height of a cone and its slant height. So you might want to say something like the height of the cone is the distance from the apex straight to the center of the cone, okay? And then it's perpendicular to the base. The slant height is the distance from the apex to the edge of the base, okay? B, compared to the height of the pyramid, the slant height of the pyramid is, what choice did you put? Hopefully A, it's longer. The slant height is always longer, okay? And then for C, you see the sides, one of the triangular faces. So if the base is 8, that means cutting in half, this will be a 4. The height is 8, it's given to you in the problem. So using the Pythagorean theorem, 4 squared plus 8 squared is c squared. I've squared both sides. That's 80. So take the square root of both sides. 80 is 16 times 5. So simplifying that radical, 4 comes out, 5 stays in. So 4 radical 5 is your simplified answer. And if you wanted an approximation, you may want to calculate that, put it in your calculator, and you would just get approximately 9 centimeters, which is reasonable with a 4/8, okay? And then for D, we have a height of 6. The base diameter is 4, that means the sides are 2. So 6 squared plus 2 squared is c squared. 36 plus 4 is c squared, that's 40. Square root of 40 would be 4 times 10. Square root of 4 comes out as 2. 2 radical 10. You want to approximate radical 40 under your square root button. I believe it's 6.3 inches approximately. All right, so you don't have to give an approximation unless it asks, but I do want you to simplify your radicals. All right, so proceed to run. Follow the directions. Have a wonderful afternoon.